Hi, and welcome to this second installment of our Xilos Cloud Chat. My name is Geert Baken.
And I'm Tim Jacobs.
And today we're going to talk about quite an interesting topic, namely machine learning. But Tim, before we start giving some practical examples, can you explain to me and our audience in layman's terms what is machine learning?
Well, machine learning is a branch of data science where you try to predict the outcome of a question that you have. Now, typical questions that can be answered by machine learning are, for example, will the customer buy this product? Yes or no? That's a binary classification problem. You also have multi-category classification problems like, is this movie a drama or comedy or thriller? And then there is a final class of problems that machine learning is very suitable for, and that's predicting numeric values using some regression techniques. What is very special to machine learning and what is different compared to traditional software and traditional programming is that you will not try to answer the specific one question that you have. So you will try to build an algorithm or a program that will answer your question and many similar questions. Now that's visualized here, where with traditional programming you have some input data that you want to ask a question about, and a program, you put it in a computer, and after some number crunching you get the output. With machine learning instead, you will provide the input data and the output that you know already is correct, so you need to answer the question yourself for the input data, and then ask the computer to produce a program that will link the input data with the output. And then with that program, you can feed it new data and get answers to questions you haven't asked before. Now, this kind of machine learning is called supervised learning, where you're already providing the answer to the question that you're asking, such that the program or the algorithm can be trained to provide the correct answer for your input data. Now, then by using some statistical methods, you can extrapolate this reasoning and this thinking to other questions and to new input data as well.
Okay, now this field of statistical learning is certainly not new, but we hear a lot more about it because of cloud. Can you explain to me the relationship between cloud and machine learning?
Yes, so as you correctly say, machine learning or statistical learning as a science has existed already for many decades, but it's only with the introduction of cloud that it got a lot of attention. So if we look at the mega vendors, Amazon introduced their machine learning platform very recently in April 2015, and that was briefly after Microsoft. Microsoft introduced their Azure Machine Learning in February 2015. There was one old kid on the block, so to speak, and that was Google. So Google Predict exists already since 2011. But it was only after the release of Microsoft's Azure Machine Learning that machine learning started to get a lot of traction amongst the cloud enthusiasts.
Okay, so now we know what machine learning is and who the key players are in the cloud. Can you give me some practical examples of where machine learning is applied in our daily lives, in computer science, and so on?
Now, in computer science, machine learning is certainly used a lot. For example, to identify spam emails. It's a binary classification problem. Is it spam, yes or no? To do document classification, which is a multi-category classification problem, but also in examples such as natural language processing, or well, probably the most famous example is optical character recognition. And optical character recognition is a very good prototype example of what questions machine learning will typically answer. There are 6 billion ways to write the letter P. What you want to do is you want to train the algorithm to recognize any way the letter P is written, so there are always some subtle variations, but still make it able to map it to the one letter, which is the letter that you're looking for. A more recent example is predictive maintenance, where you will use sensors to detect anomalous behavior in machines or in components, and then by detecting how this anomalous behavior is related to the failure of the machine, you can put a number on how long the machine can still run without problems. And then that same type of anomalous behavior detection is also used in fraud detection, which is also a very hot topic in machine learning. And then finally, in autonomous systems, for example, self-driving cars, or basically any system where you need to put in some type of intelligence, there also machine learning plays an important role.
How is it done now? I mean, in practice, how would you go about using machine learning?
Well, what is important to realize is that there is a flow that you need to go through. So there are, in fact, 4 steps that you need to pass through. And well, everything of course starts with data. And you don't need just any data, you need data that is relevant to answer the question that you want.
And does the cloud provider, or do the cloud providers help you like also obtaining data sets, for instance, that you might use in your own solution?
The Microsoft offering, Azure Machine Learning, has an entire marketplace where you can buy readily made models that are already trained, so that can predict for specific questions the answer, and also the data sets or generic data sets that you can use in your own application.
Interesting. Yeah.
Now, once you have the data, the next step is to clean up and transform this data. This is probably where you're going to spend 60 or 70% of your time during the machine learning process, because the data needs to make sense. In any real-life situation, your database probably has some missing fields or data that is not within categories that you would expect. So you really need to go through all this data and clean it up.
Do cloud providers help actually in cleaning up the data, randomizing the data, enriching it, or is that something you really have to do all by yourself?
Well, we will see in a few moments that in the case of Amazon, you have to do all this work yourself. But if you look at Azure, there Microsoft provides you with the possibility to execute Python scripts, to execute R scripts for data scientists, to transform your data on the fly. So certainly the Microsoft solution has the added advantage there of providing at the disposal of data scientists a very broad range of tools to process the data as it enters the cloud. And then finally, when you have your data all cleansed, you can put it into the machine learning algorithm and it will generate you a model. And this model can then be used to make predictions. And what is very interesting about machine learning is that you will feed back the predictions that you make to your training process, such that the machine learning model gets more and more intelligent as it processes more and more data. Start with a small set of data, and as it gets used more, your predictions will get more accurate.
Okay, so now let's have a look at how to do this with Amazon machine learning.
The example that we're going to look at is one where machine learning will predict us based on the characteristics of a mushroom, whether it is poisonous or whether it is safe to eat.
That's handy. This will come in quite handy this weekend for me.
It's very, very good to know. Now, everything starts with a good data set. So we see here that based on characteristics like the odor of the mushroom, like how the cap looks like, we already have here the answer whether the mushroom is safe to eat, which is a 1, or whether it is poisonous, which is 0.
So these are all correct answers.
Correct. Some biologist has already entered all the characteristics of about 6,000 different mushrooms and whether they are poisonous or not into a database that we're using here.
And we're sure that guy was right.
Well, let's certainly hope he was. Okay, now this data, we have the attributes that we know and we have already the answer, and this we can feed into a machine learning model. Now let's have a look at Amazon. As you can probably expect with Amazon, either the data needs to be in Redshift or in S3. So I already uploaded this data to S3. We're going to select it here. So it's our mushroom data that we have prepared and cleaned up already. We will give it a label, XCS mushroom, just to upload.
So from simple data in Excel, you just drop it in a folder on S3 and you can start.
Yeah, exactly. So
Great.
it's really preparing the data, uploading it, and importing it.
Yeah.
The Amazon Machine Learning Engine will immediately start looking at the data. So first of all, it will look at all the columns that we have defined. Now, in this case, our CSV contained column names. And for every column, the Amazon Machine Learning Engine will try to detect what type of attribute is in the column. So for example, the bruises column, it's a binary value. Things like odor is a category where there are several values that are available. And what is most interesting to us is, of course, the safe column, which is also binary in this case, which is either 0 or 1 for poisonous and edible. Once that we have checked that everything is correct, we need to prepare the data for machine learning. So that's the question here. Do we want to use this data for the machine learning model? The answer is, of course, yes. And what we need to select here is the answer to the question that we try to solve. So in our case, we're going to indicate that the safe column contains the answers to the question, is this mushroom poisonous or not? So now that we are ready, let's continue here. We get finally an overview and we click on finish. So you see that importing data into Amazon is really a next finish process. Okay, Amazon will start analyzing this data. It will take a few minutes to do this. Now, I already took the liberty of uploading this same data set. Okay, once the data is in place, we can construct a machine learning model. Now, this is done by creating a new machine learning model. And here we can select that we have already the data present. Creating a machine learning model is again an almost equally simple next finish process. Here we will use, here's the name for our model, and we're also going to evaluate the model. So what is interesting to know is that Amazon will split the input data into two parts. So 70% of the data is used to train the model. So in 70% of the data, Amazon will look at correlations between the attribute and the answer to the question. And 30% of the data is used afterwards to check how correct the model was. So that means that with our own data set split in two parts, one part we use for training and the other part we use for checking how correct the algorithm in the end will be. We press review here, and again, it's as simple as pressing finish here to allow the machine learning model to be generated. Now, this takes quite some time. You will see in the screencast of Azure that it is almost instant. It takes between, I think, 5 or 15 seconds to generate the entire model with Azure. Okay. Here at Amazon, it takes a bit more time. It takes about 10 minutes to do all the processing of the data and to do the entire evaluation. Now, once that you are done, you can check the performance of your model by looking at the evaluation that Amazon will automatically start for you. And in this specific case, we see that our model is very good. It is 100% accurate in predicting whether a mushroom is poisonous or not.
Okay, so this means that when I find a mushroom in the forest, I enter the data, I can be sure that it's either poisonous or not.
Well, if you want to take that risk and if you put me in your will, then certainly you should do it.
Okay.
Of course, the reason why it is, and Amazon is very correctly pointing it out, this is simply too good to be true. Mm-hmm. The reason is that this data set was especially crafted for machine learning applications.
Okay. Okay, so now you have the model. Yeah. How do you now feed it with other data, new data, to do your predictions? Yeah. How is that done?
Well, to do that, there are two options in Amazon. Either you upload a comma-separated file with all the characteristics, well, in this case of mushrooms, and on this batch of data, it will do a batch prediction. So it will answer the question poisonous or not for every line in this comma-separated file. Mm-hmm. Or another way is that you use the Amazon APIs to upload the data, for example, from a mobile application that you've written, and then get a real-time prediction. Let's have a quick look at that.
You had to use Eclipse instead of Visual Studio, of course.
Yes, yeah. That's because real men use Eclipse. So I wrote a small Python script that will connect to the Amazon Machine Learning API, and that will feed it with some data. So we provide it with the model ID, which is something you can get from the UI, and then we feed it with all the attributes of the mushroom that we have. So I took some random mushroom I found in my backyard, and I entered it here. And then what happens next? You connect to the machine learning API. Okay, we do some sanity checking, which is just to have nice code. And we ask the machine learning API to make a prediction based for the specific model ID that we're working, for the data that we have.
And you get back a 1 or a 0.
That's correct. So you immediately get back a prediction. And well, depending on what the Amazon API thinks, we will either respond with whether the mushroom is safe to eat or whether it is poisonous to eat.
Okay, let's run this.
Yeah, so it's very simple. In this case, we just run, it processes the script. And in our case, the mushroom with these specific characteristics, which are not in the data set, is estimated to be poisonous to eat.
That's the actual value you get back from machine learning?
Yes, so in this case, it is 0.009, which is very close to 0, which means it is very correct to say that this mushroom is poisonous to eat.
Okay, so basically any developer can actually then start using this model to do some predictions.
Yeah, that's correct. You see from the simplicity of creating this machine learning model, it's very fast, it's very easy, so it's really geared towards, well, either tech-savvy end users or to developers who just need some, well, intelligence that's good enough.
Yeah.
So if
Okay.
you look at Azure, you can go much further, can do much more processing and transformations of your data. It's really for data scientists. But if you don't want to delve into this world, then the Amazon solution is really a next finished approach to machine learning.
Okay, that's it for the second installment of the Xylos Cloud Chat. Bye bye.
Bye.